So now we'll talk about inequalities. So we go straight into examples. 1, check if the first paper is on inequalities. Yeah, this one had. Solve. X squared minus 4x minus 5 is greater than 0. 2, nothing else. Yes, solve 3x over x minus 2 and x minus 1 is less or equal to 0. We also put things like this one. The absolute value of x plus 1 over x minus 3 is greater than 4. Let's try this also. It's interesting now. Solutions. Question 1. We have x squared minus 4x minus 5 is greater than 0. This is a quadratic. There are two ways. If you want, you can sketch it if you're able. Directly, that is. If you're not able, then you factorize it. So let's factorize this. It looks like it has factors, -5 and +1. So say x squared plus x minus 5x minus 5 is greater than 0, which is x plus 1, and minus 5, x plus 1 greater than 0, which is x plus 1, and then you remain with x minus 5 are greater than 0. Then we call these, we now find the critical values. How do we find critical values? We equate each piece here, these pieces forming the product, we equate each to 0, so that we get x is equal to -1. We equate x minus 5 to 0, so that we get x is equal to +5. These are called critical values because if you place them in the function, they will give us 0. And 0 is neither bigger than itself nor less than itself. So it can tell us which side this becomes positive or negative. And then we form a table using these two. So we'll put -1 and +5. Draw lines demarcating the two. Then we look for a number that is less than -1, any random number, say -2. We also look for a number that is between -5 and +5, say 0. We also look for a number that is bigger than 5. Let's say 6. Then you get these pieces, x plus 1. We also get x minus 5. And then we demarcate here. And then we have the P representing the product since we are multiplying these two. When x is -2, we get -2 plus 1 if you use x plus 1. This will give us -1. From -1, you just pick the negative, because someone else could have used -10 here. They can still get -10 plus 1. They will have -9. What is common between the two is the negative. So you put a negative here. If we use -2 in x minus 5, we'll have -2 minus 5, which is -7. Again, we just pick the negative. P is x plus 1 multiplied by x minus 5. So we have negative times negative, which is giving us positive. So we put positive here. We go in the second column, where we have chosen to use 0. If we substitute 0 where there is x in x plus 1, you get +1. If you put 0 where there is x minus 5, you have 0 minus 5, which is negative. Then you have positive times negative, we get negative. If we use 6 in x plus 1, we get 7, which is positive. 6 minus 5, we get 1, which is positive. And positive times positive, we get positive. The question says greater than 0. So when it is greater, it means it is positive. So you say the solution set, you pick the P, the product, the signs of the product. That is from -infinity all the way up to -1, not included, union 5 all the way up +infinity. How do I know? Now I include, now I exclude. If there is only greater, you don't include. If it was greater or equal to, then you include. Do we have questions here?
No.
Okay, cool. Let's go to question 2. 3x over x minus 2 and x minus 1 is less or equal to 0. So here, the denominator is already factorized. For the first question, we had to factorize the denominator. I mean, we have to factorize the left side. But in this case, we have the denominator factorized, the numerator factorized. So we just go straight to critical values. So we'll have 3x is equal to 0, giving us x is equal to 0. We also have x minus 2 equal to 0, giving us x is equal to 2. We also have x minus 1, giving us 0, giving us x is equal to 1. So these are the critical values that we use on the table. So we'll have 0, 1, 2, and then draw lines. Demarcate. And then we pick So we have 3x in the numerator. We'll have x minus 2 from the denominator. We also have x minus 1 in the other denominator. And then we'll have, let's call it q now, just to mean the quotient. Really, this means nothing. You can put anything here. You can put even the same p, you can put a for anything that you put. And then we pick a number that is less than 0, say -1. A number between 0 and 1, say half. Number between 1 and 2, 3/2. Number bigger than 2, say 3. Then you start substituting now on these left numbers. -1 and 3x, it gives us negative. -1 minus 2, negative. -1 minus 1, negative. Negative times negative times negative, we still get negative. Then in normal cases, you expect to have a positive here, to have a minus here, to have a positive here. But you can confirm, you can check. So if we put a positive here, if we put half, we get positive. If we put half, we'll have half minus 2. This is 1 minus 4/2, which is -3/2, which is negative. And then half minus 1, that's 1 minus 2/2, which is -1/2, which is negative. For sure, and you multiply positive times negative, you get a positive. Then 3/2, this will be positive. Then you have 3/2 minus 2/1. That is 3 minus 4/2, which is -1/2. So we get minus. And then 3 minus 3/2. That's 6 minus 3/2, which is 3/2, which is positive. When you multiply the 3, you get the minus that we found here. Then 3, we have a positive. 3 minus 2 is positive. 3 minus 1 is positive. So we get the positive there. Then the solution set. Remember, we're looking for less or equal to 0. So we go for the negative. This is less than 0. This is less than 0. So we'll pick from -infinite up to +0, not included. Then you check now the right one. Do I include it or not? The question is, because you have less or equal to, it must be included. But you be careful a bit, you check if it is coming from the numerator or the denominator. Where did we get x is equal to 0? It came from 3x, which is in the numerator, so we include it. Union, another negative is from 1 to 2. Where did we find 1 and 2? In the denominator, so we don't include them, even if we were supposed to, because should we include it, your denominator is going to be 0. And once you have 0 in the denominator, everything becomes undefined. So this is the solution set. Must be super cool, eh? Okay, we go for question 3. The absolute value of x minus x plus 1, x minus 3, x plus 1, excuse, x minus 3, this is greater than 4. Yeah, that's the question. When you have greater, you write this as plus or minus 3 plus x plus 1 over x minus 3 is greater than 4. The plus one is telling us that oh yeah, this is x. So I see why. This is x. So this is telling us that the positive x plus 1 over x minus 3 is bigger than 4. Or the negative x plus 1 over x minus 3 is bigger than 4. So the left one, we put 4 the other side so that we get x plus 1 over x minus 3 minus 4 over 1 is bigger than 0. We never cross multiply here for a simple reason that the negative is not decided in the numerator. We don't know whether it's negative or positive there. So the common denominator is x minus 3. And then we'll have x plus 1 minus 4, open brackets, x minus 3 greater than 0. Then we get x plus 1 minus 4x plus 12 over x minus 3 is bigger than 0. So negative 3x plus 13 over x minus 3 is bigger than 0. So we'll have negative 3x plus 13 is equal to 0, so that x is 13 over 3. X minus 3 is equal to 0, so that x is equal to 3. Two critical values, so put 3 is less than 13 over 3. But 13 over 3 is like 4 point something, because 12 over 3 is 4. So 4 is in between. And then here maybe we can use 6 to be safe. And here you can use 0. And then we pick negative 3, x plus 13. We also pick x minus 3 and pick q for the fraction. And then demarcate here. Demarcate here. Goes down. Goes to side. This side. This side. Comes here. Comes here. Comes here. Well, if I place 0 where there is x in negative 3x plus 13, I'll get positive. If I place 0 where there is x minus 3, I'll get negative. The product is minus 4. That is negative 12 plus 13, so we get positive. And then another positive for 4 minus 3, so we get positive. Then 6, that is negative, then positive, then minus. So the solution set 1, we'll call it 1 because we're not yet done. So we'll call it 1 greater than 0. That is from 3 to 13 over 3. None of them included because it's strictly greater. Then we move to solution set. The other one. Then we move to the other one. Where we take for the other side again. So this time around, remember we have a negative x plus 1 over x minus 3, and then minus 4 greater than 0. So 4 over 1. The common denominator is x minus 3 again. Then we have minus x plus 1 minus 4 x minus 3 is greater than 0. Then we get negative x minus 1 minus 4x plus 12 over x minus 3. This is bigger than 0. Then we get negative 5x plus 11 over x minus 3 bigger than 0. And the critical values, that will be x is equal to 11 over 5 and x is equal to 3. Like this. Then now, another table. So 11 over 5 is less than 3 and then 3. So a number bigger than 3 can be 4. A number in between 11 over 5 and 3 is going to be, that is 2. This one has to be a bit careful. So what we do is we just add the two numbers. 11 over 5 plus 3 over 1. We get 5 down, 11 plus 15. This will be 26 over 5. That be good work here. Oh yeah, then I divide this number by 2. So it becomes, I was wondering. So it becomes 26 over 10. Or we just write 13 over 5 now. Yeah, 13 over 5. And then a number less, we can use 0. Then we pick negative 5x plus 11, x minus 3, and then Q for the quotient. Then we do the testing. So once I find the first, then I'm done. When you put 0 there, we get positive. 0 here, get minus. So we have minus. So this will be positive. This will be minus. So you can finish up the table to confirm. So that you see that this also works. But we require you to finish the table. That's for confirmation sake. And then the solution set, okay, we're going to call solution set 2 here. This is supposed to be bigger than 0. So again, this is happening at 11 over 5 and 3, not including any. Then you get solution set 1 union solution set 2. So here you get union. So we have 3, 13 over 3 union 11 over 5, 3. Combining this is just the same thing as 11 over 5, 3 union 3, 13 over 3. Well, we just rewrite them for it to make sense. Otherwise, we can't put this together because the bound is on 3. I mean, that's where they're separating. And 3 is not included anywhere. So it's like a line of this nature. When it reaches 3 to be open, and then it goes. So it's starting at open at 11 over 5, open at 3, and then it continues open at 13 over 3. That's like how our interval is. Okay, so This should be enough for semester 1 now. And this is what we'll do now. So what I mean by semester 1 is the semester 1 examine part. This is what we've been doing. So on Saturday, yeah, I'll post in the group. So on Saturday, we'll look at polynomials. A quick one, so that then we head into trigonometry. So I'm sure on Saturday we'll just do this one. Then when we open, those guys based on campus will be in urban trigonometry. The guys based at Ridgeway will be in, we'll finish up at trigonometry and then I'll assess you. So on Saturday I'll do polynomials in a well-arranged way, and we'll finish it because 2 hours is enough. So finish polynomials, do all the whole factorization thing, method of division, and then sketch in some applications there, so that we move to trigonometry as we open. So I'll post this. I said I'll post this in the group. I don't know what time, but maybe before I sleep. So you can have a good night. Jackson, you're saying something?
Yes, the previous